Okay, so we have looked at the quadratic functions in Vertex form, and we've been able to identify our A, our H, and our K. So what else, what other information or key features could we get from a quadratic equation or quadratic function written in Vertex form? So let's look at this example here. We're going to do f of x equals 2 times x minus 3 squared plus 4. Okay, and I'm going to go ahead and write that formula. You'll always catch me doing that. Just the more I write it, the more I know it, and it really helps me kind of visualize what number is in what place. Okay, so let me go ahead and color code here. I see in my place of A is a 2, so that tells me it's a slope of 2. It's a positive, so it will be open upward. So the more you say this out loud and the more we do these together, you're going to be able to answer these much quickly and you'll get more comfortable, I promise. But you'll hear me saying it out loud as well because I want to get better at this as well. Okay, so there we go. We have our A is 2, our H is a positive 3 because our sign did not change, and our K is a positive 4, again, because our signs did not change from the original formula here. Okay, so let's go ahead and draw my kind of a rough draft here of a rough sketch, I should say, of my coordinate plane. We know our parent function starts at the vertex 0, 0, has a slope of 1, and it should open upward. So that's where we begin. So let's break this apart. Okay, this is a positive number, so since it's positive, that means it opens upward, and it is greater than 1, telling me it's a vertical stretch. So it should be a little bit skinnier. Okay, and then my vertex comes from my H and K values. Remember, H before K, walk and then climb. And my H and K are a positive 3, positive 4 because our signs did not change. Remember, I'm going to go ahead and add this in here. This is our vertex. That's that point of symmetry where it cuts that parabola in half. So we know we could fold that over and it would lay perfectly. Okay, so let's graph this, see what it looks like. And then we'll talk about a few more key features that we can get from this graph. We'll talk about review some words from Algebra 1. Okay, so I'm going to walk 3, climb 4, so it's going to be right up here somewhere, and it has a line to open upward, and it has a slope of 2. So I'd like walk 2, climb 1, so it'd be somewhere right there. And I'm aware our graph's not going to be perfect, but at least you have some visual aid of an idea of what it's supposed to look like, okay? All right, so that is what our graph should look like. And so what other information can I get from this graph? So we know the vertex is positive 3, positive 4. Let's talk about the axis of symmetry. That's a review. The axis of symmetry is where our graph has been cut vertically in half here. And you see it's not perfect. Okay, the axis, it's like if I took this y-axis, right? This is the axis right there. But we're looking for the axis of symmetry. Where is this parabola being cut in the middle? Well, it's being cut at positive 3. And we have to be careful. Sometimes we forget to write that as an equation. It is when x is equal to a positive 3. Okay, so we want to make sure we use that equation. Also, we can tell the domain and range. If you remember that, domain and range of this graph. Okay, domain, remember, is your walk, is your x, range is your y. So walk before you climb, domain before range, H before K. Do you see the pattern here? So our domain is how our graph is traveling, and we're explaining it left to right. So if I follow this parabola here, it is going up, but it's slanted, so it's going towards the right, and it will always go towards the right. So way up here is going to keep going up and to the right, up and to the right. So it's going to go forever and ever to the right, and then when I follow it to the left, it's going to go forever and ever to the left. So we say if it's all numbers right and all numbers left, it's all real numbers. Okay, so let's talk about the range. Well, the range isn't going to be all real numbers because it doesn't travel down forever and ever. It starts right here at +4. And this is where we are going to review interval notation. So it touches at +4. So it's a closed circle at +4, meaning you'd have a bracket at +4, and then as it climbs up, it goes forever and ever. It never stops. So it's going towards positive infinity, and remember, infinity always gets a parentheses. If you think about it, we can't ever actually find infinity and put a point there, so it would never be a closed point at infinity. So it's an open circle, so we use a parentheses there. All right, so here we go. We have our domain, we have range, axis of symmetry, and our vertex. All of this information we were able to find from that one graph.